Okay, good afternoon everybody. My name is Mikko Mönkkönen. I come from University of Jyväskylä, where I'm a professor in applied ecology. For the past 15 years or so I've been interacting and doing collaboration with economists, and particularly environmental economists. So I couldn't resist the invitation by Uskali when he invited me over to this discussion. I think this is hopefully very useful and fruitful event. So I will first provide, from my point of view, some insights. First of all, I will define what ecology is, and then also trying to define what economics is. And then, based on my own research, I will give an example showing a blind spot in the current way economics, natural resource economics, put value on things. And I argue that the current economics approach is too narrow to capture the full value of ecosystems and ecological attributes out there in the nature. And then I will also touch upon this concept of ecosystem services and how we put value on ecosystem services, and why economic analysis alone is not sufficient in solving environmental problems and the question of sustainable use of natural resources, including ecosystem services, including natural resources. And finally, I will touch upon the concept called resilience, which I think is a future challenge for ecological economics to tackle with. So, definitions. When we first start dealing with ecology, it's a kind of a traditionally, if you take a textbook of ecology, the definition is that it's a scientific research on how individuals, populations, and their communities interact with their environment. But if you look at the original definition of ecology by Ernst Haeckel, a German zoologist from 1870s, he said that he defined, this is the first definition of what ecology as science is. It's a body of knowledge concerning the economy of nature. So investigation of the total relations of the animals. Well, he was zoologist, that's why he was pointing out the animals, but basically organisms to its inorganic and to organic environment. And it derives from Greek words oikos, which means house or dwelling or habitation. So it's a place where organisms live. And logia is a study of house or dwellings or habitation. So right from the beginning, ecology is a kind of an economic research on how organisms are related to their environment. And also derived from this Greek words or the etymology of the word ecology, it is obvious that ecology is, at least to some extent, tied to very place where ecological processes happen. That's why it tended to be small scale in the beginning. It's the environment where organisms live. Whereas economics, it's a science that addresses how to allocate scarce resources among alternative competing ends in market systems. So, for example, how individuals and societies relate themselves to resources they use, sharing, refining, and trade. So, in a way, we can see from those definitions that economics is human ecology, how humans relate themselves to their abiotic and biotic environment. Whereas, as we can see, we saw already in Haeckel's original definition, ecology is the economics of nature. So I see that there are lots of things in common between these two areas of research. Right from the beginning, I think the logic behind these two approaches and two areas in science are pretty similar. But there are differences, and particularly differences in the regimes that they are dealing with. And that's one thing that I'm going to discuss next. I promised to give you an example from my own study. And in this particular project, we address questions like how to maintain economically and ecologically sustainable forestry at the landscape scale and in the long run. So large scale, long-term, sustainable use of our forest resources. More specific questions in this particular case include like, what is the optimal combination of management that provides maximum amount of timber and is able to maintain, for example, maximum amount of timber and at the same time able to maintain biodiversity out there in the forests. And in this case study, our study area is in central Finland. It's a large landscape consisting of 30,000 individual forest stands that we have been simulating 50 years into the future with 7 alternative management regimes. Those management regimes include management types like the recommended intensive forest practice in Finland, including clear cutting, planting trees, thinning, and so forth. Kind of a traditional business as usual forestry, Finnish forestry. That's the one end, opposite end of the continuum. On the opposite end is total set aside, and 5 different regimes in between, varying from very intensive to no forestry at all. So you can just imagine how large is the number of combinations that one can get. You have 30,000 forest stands 50 years in the future with 7 alternative options. So we basically know 7 alternative future trajectories for each of the forest stands.
So,
yeah.
Can you just define forest stand?
Forest stand is usually, in this particular case, it's like 1 to 2 hectares of forest, which is more or less.
So it's the 45.
Yeah. More or less homogeneous stand of trees. Okay, this is one example and one result from our research. Typically, the relationship between the amount of money you can get out of the forest within the 50 years time window is in trade-off between biodiversity. Here we measured biodiversity as habitat availability for species living in forests. So the more you reap money out of the forest, the less there tends to be habitats available for the species living in forests. The good thing is that the trade-off is not linear. So you can increase the habitat availability of species with fairly little cost. But in this particular case, there's one important point in space and time. And that dot, which is the recommended management. If all the forest stands in the landscape are managed according to the recommended management regime, meaning this business as usual scenario, we end up being in that particular spot in this area. So it is a little bit below what is optimal. This curve represents what is the optimal solution. You can't get higher than that curve, but obviously most of the practical or the current solutions are below the optimal curve. That's the absolute maximum level you can get. So this point refers to amount of money and amount of habitat if all stands are managed according to recommended management targets. And we can calculate that this management using recommended forest management results in approximately 10 million euro loss in terms of money, or 5% of the total net present value in monetary terms. But in ecological terms, it results in much higher loss of welfare. if we include biodiversity as a part of welfare. So depending on species, current recommended management results into 30 to almost 300% loss of habitat. It means that actually with careful enough landscape level forestry planning, we are able to increase habitat availability quite much even without any additional costs. That's the point. And my question here is that why society is willing to pay this high ecological policy cost? This economic policy cost is fairly small compared to ecological policy cost. So the question is why society is willing to do this. Why do we have this high ecological policy cost? And I think the reason lies in current way how forest economics is applied and done. We are dealing with multiple use landscape or multi-objective landscapes. And in this case, multi-objective landscapes means that at the same time the landscape, in this case it's forest. Forest landscape is expected to provide good and benefits for the society, at the same time maintain biodiversity and related ecosystem functions and services. And these three things or requirements are related to each other, so that the way we keep the goods and benefits from the landscape and the amount of goods and benefits that we reap from the landscape has a direct effect what is the current state of biodiversity in the landscape. And we know from ecological studies that biodiversity and ecosystem service functioning and services are related. Because biodiversity species and their populations and communities, they are the structure on which ecosystem function. And ecosystem functioning is the basis for ecosystem services. So, and ecosystem services finally then create or produce goods and benefits from the human society. I will not go into details of these 6 facts about biodiversity with respect to ecosystem functioning. I just refer to this Cardinals et al. Paper in Nature last year, saying basically that we know quite much about what is the relationship between biodiversity and ecosystem functioning. For example, we know that biodiversity loss reduces ecosystem functions. We know that biodiversity increases the stability of ecosystem functions through time. We know that the more diverse communities are more productive and so forth. These are hard facts that ecological research has been able to provide. Let's go back to this concept of ecosystem services. Ecosystem services are benefits that human societies get from the functioning of the ecosystems. They are here in the middle. And we know that ecosystem functions are based on, ecosystem services are based on ecosystem functioning. And this ecosystem processes, this ecosystem functioning is based on biodiversity. That's already what we know. And how these ecosystem services are then translated into goods and benefits for the society. That's what economics is all about. Actually, current economics, to some extent, is able to take into account ecosystem services. Traditionally, economics only treated ecosystem services as an input. But lately, there has been so-called total economic value research trying to take into account also ecosystem services part. But ecology, that's a science as Haeckel defined. It's a total economics of nature, including the ecosystem structure, functioning, and the consequence ecosystem services. And it also includes the feedback loop from human actions back to ecosystems and their processes. So ecology, right, is essentially a holistic science able to deal with interactions between natural ecosystem and human actions. Then I have listed a couple of things. This is an exhaustive list, but not exhausting, I hope. Just a few items to show why I think, or why many of people, researchers dealing with natural resource economics tend to think that economic analysis alone cannot be the answer. First of all, if we only look at economic value, it is evident that current economic value depends mainly on certain functional species or species group. And if we only look at what is the current value that we can right now get or read from the ecosystems, we end up losing a lot of species, because why to have more species than just those few that contribute to human benefit? So mere economic valuation of ecosystem services and goods and benefits that we reap leads to loss of biodiversity. Ecosystems also behave unpredictably and with time lags. And if you only look at current value of ecosystems and their services, there's a danger that that loss of species and resilience, which is the long-term potential of the ecosystems to process and provide this benefit, will go unnoticed. Because some species can be lost without no changes in ecosystem services. And that's why economic value does not reflect ecosystems' ability to maintain future provisioning of services. It is because economic analysis doesn't take into account the underlying processes of functioning ecosystems. It only deals with the ecosystem service part and the goods and benefits, direct goods and benefits from the ecosystem, but not the essential processes that lie behind these goods and benefits. Third, values based on human preferences. They tend to reflect policies, subsidies, all sorts of operations of the society. And thus, they indicate the true value for the society only by chance. That's one of the criticisms that have been raised. So, to summarize, economic analysis is the output, economic value is the output of ecosystems at one point in time and space. It is not the state or the long-term capacity of the ecosystems to provide these services. It doesn't take into account, it is kind of applied to ecosystem stability or resistance, meaning what is the capacity of the ecosystems to provide a stable flow of ecosystem services in time, and how much they are able to resist human disturbance. It is also applied with respect to ecosystem resilience, which is the long-term capacity of the ecosystem to provide these services and benefits. And it is, to some extent at least applied to intergenerational sustainability, the future generations' ability to get benefits and services from the ecosystem. So in other words, economic analysis does not alone help in solving how to manage sustainable use of ecosystems. Whereas ecological analysis, as we already saw, it's non-anthropogenic, it deals with natural capital. It deals with the ecosystem structures, the biodiversity part of the ecosystems. That's built in the ecological analysis. So natural capital, natural stock is built in ecological theories. Ecology directly considers complexity, structure, stability, resilience. Those are the key concepts of ecological analysis and theory, as well as flow of natural capital in space and time. We have ecological research such as landscape ecology or macroecology that directly deals with large-scale, long-term aspects of ecosystems. And sustainability is a core concept in ecological analysis and research. That's why I think ecological value is more comprehensive than economic value when we deal with, for example, ecosystem services and value of ecosystems. Final words about resilience and sustainability. And as I said in the beginning, this is kind of a challenge for future research in environmental economics. Resilience is ecosystems' ability to maintain the provisioning of ecosystem services into the future. I pose a question. If we are able to maintain long-term intergenerational resilience, isn't it more valuable from sustainability point of view than large economic benefits right now? In other words, should we give more or at least equal emphasis on future than present value? And this is in sharp contrast with current economic thinking, which tends to put more emphasis on current values that you can read from the ecosystems. You know this discounting of values. The further away in future the values are, the less is the amount because of discount. But my question is, shouldn't it be the other way around when we talk about environmental benefits and environmental values? Thank you.